Yes. Please take out your notes. We're going to move around. We got to keep a quick tempo today in order to keep up. So please do your best to follow along. And also, please make sure that you're engaged. So now that we understand about bearings and we know about laws of sines and cosines, we're going to be better suited to handle some of the word problems that we see. It says, in example 1, point A is due north of point B. Point C lies to the west of both. AB is 12 inches, BC is 13 inches, AC is 15 inches. What is the bearing of C from B? I would never ask you this question. I would say B to C. And C from A, I would say A to C. Okay? I will always use the word to in between those and not from. Okay, from would be switched around. So sorry for that confusion. So I'll draw a picture. Point A sits up there. Point B sits to the south. And C sits to the west of both of them. As I draw my picture here. I know that AB is 12, BC is 13, AC is 15. And the question is, what's the bearing B to C and A to C? Well, tell me in general, if you were to walk from B to C, what would be the general direction you would travel? Northwest. If you walk A to C, you would travel southwest. We need an actual number to attach with that. So what do we need to find here that we don't yet have? An angle. And if we want to find an angle in a side, what are we going to have to use? Law of cosines. Which angle, if we're using the law of cosines in a side, should we be solving for? B, because it's opposite the largest one. Very good. So I'm going to solve for angle B. So I would say 15 squared is equal to 13 squared plus 12 squared minus 2 times 13 times 12 times the cosine of B. So that's the law of cosine set up for us, which you're excellent at solving because we've had adequate practice for it, and you've done a good job. Generally speaking, we like equations. I get that. So 15 squared minus 13 squared minus 12 squared divided by, parentheses, I got now divided by the negative 2 times 13 times 12, right? I subtracted the 13 squared over. I subtracted the 12 squared over. And I'm going to divide off the coefficient that's in front of the cosine. So I divide off negative 2 times 13 times 12. And I get that. Cosine inverse that result, 73/62. Questions? How I come up with that? That's old learning, right? We've done this before. Okay, so 73/62. Let's just solve the whole triangle. Okay. If there's an obtuse angle, that would be the one, right? So we know the others are acute, so there's no danger in using the law of sines right now. So we'll just set up sine of what? 73.62 over 15 is equal to sine of A over 13. Very good. We cross multiply and we inverse. $56.25. Did I find C now? But I don't have to. Okay, it's not relevant in this situation. So what I'm going to do is now that I have these two angles, I can finally answer this question. B to C. From north, I turn how many degrees to the west? 73.62. So north, 73.62 degrees to the west. We'll do that for A, but so we're going to go 360 minus 73.62, and we get 286.38. What? I just gave myself the I wrote it two ways, 286.38 and north 73.62 west. You told me it was in the northwest direction, correct? So that's why I come off the line of north. Now I will do A to C. And as I go from A to C, from the south line that Fran was talking about, I will turn how many degrees to the west? 56. So from south, I turn 56.25 degrees to the west. Or from 180, I will add 56.25. I get 236.2. And there they are. How's that? Not too bad. So this is a word problem that is essentially the same as the problems we did just the past couple days, right? We just didn't find all the pieces. Any questions before I move on? 3 times sold. Okay, we are going to skip to a page that looks like this right now. And we're going to do problems 2 and 3. Be a Tigers Roar on Friday night, so I'll enjoy watching you guys. Thought somebody would be more excited about that, but maybe I'll just stay home. We'll get right back to it. Okay, all right. So this is a great example. I love this kind of problem because it's similar to some things we've done before. It just involves bearings and the law of cosines. Two ships leave a port at noon. What actually came out of my mouth was schlips, but there's a. All right. So this one. This is a good problem. We like this one. 2 ships. That's where we got started. Okay, 2 ships. And here is your line. Okay, and so those are our coordinates. It says ship A is traveling at a bearing of north 32 west. Ship B is traveling at a bearing of south 75 east. They're traveling at different speeds. How far apart are they at 4 p.m.? So we've got to dissect this a little bit. Let's talk about the direction first. Okay, north 32 west. So I would say that would be about like that. Is that all right? So I know that this angle right here is 32 degrees. The other one is south 75 east. So that would be more like that, correct? So if that's 75, then this little one here is 15. I'm wondering how far apart they are. I'm wondering this distance. Oh boy. I could use some distances. Let's see. They leave the port, so they leave this spot and they travel. So if they're traveling at 5 miles an hour, how many hours have they been traveling for? They left at noon. What's the current time? 4. So they've been traveling for how many hours? 4. And if they've been going 5 miles an hour, they've traveled a total of 20 miles. So this one's traveled 20 miles. The other one's traveled 16 miles. So I've used just a little bit of insight about distance, rate, and time to figure out how far they've traveled. And now what I also want to know is this angle right there. So I've got, yeah, very good. So I've got 90 degrees plus 15 degrees plus 32 degrees. 137. What? That's all right. 137. There you go. That boy. I want to find D. What do I use? Law of cosines. Because, look, you're given a side, an angle, and a side. Side, angle, side. So side, angle, side says we use the law of sines, or cosines. Law of cosines. Because we would use the law of sines if we had an angle and its opposite side. We don't have an angle and its opposite side. We got two sides in the included angle. So D squared, if we want to find that, we would take 20 squared plus 16 squared is 2 times 20 times 16 times the cosine of 137. So what I like about this problem is you just plug everything in. Is that my answer? No. Square root. Very good. Because the law of cosine says a squared plus b squared minus 2ab cosine of c. They've been traveling for 4 hours. From noon to 4 is 4 hours. 5 miles an hour would be 20 miles. 4 miles an hour would be 16 miles. Whoa. Oh, I'm sorry, Fran. Fran's absolutely, you guys, I didn't write it wrong there. I punched it wrong in my calculator. I wasn't looking at the calculator. 20 squared plus 16 squared minus 2 times, I hit the minus sign, times 20 times 16 times the cosine of 137. There we go, and square root that, and we get, there we go, 33.53. Hit the wrong button. Do you think they actually do this in real life? Yeah. Yeah. I mean, you had a plane disappear, in the Indian Ocean, and they're trying to figure out where it could be, and they calculate wind currents and everything else to try to figure out what happened to it, where it could be floating, and where to look for it. Yeah. Yeah. Okay, we're going to change this one. 33. So instead of north 70 degrees east, we're going to go north 20 degrees east. Okay. We got a plane. It's flying at a bearing of north 80 degrees east. That's almost straight east, right? So that's kind of like its general path, something like that. Traveling at 80-degree bearing. You okay with that? Okay, and somewhere along that path, it turns. So after it's gone 300 miles, it turns. I don't know why. Plane turns and flies 400 miles at a bearing of north 20 degrees east. So straight north would be like that, but 20 degrees to the east, so flew something like that. And it flew that direction for 400 miles. So the question is, how far is it from its original starting position? So I've got two sides, I've got no angles, and I want to find D. Pythagoras is a great option. That requires us to have a right triangle. We don't have that. What do I have to find? Okay, so something with the angle. So here's the trick. Here's the trick. Oh, you want to make the other triangle? It's a good idea. But it doesn't work. So we fly at an 80-degree bearing, and we turn to a 20-degree bearing. So what was our turn? We turned 60 degrees. If you know that 60, can you find your other angle? What is it? 120. Now you've got what kind of triangle? Side, angle, side. If you have a side, angle, side, which one do you use? Well, I'll have cosines to find the opposite side. D squared is equal to 300 squared plus 400 squared minus 2 times 300 times 400 times the cosine of 120 degrees. What? Is that my answer? 608, 28. Does that make sense? It's longer than the other two. Just got the biggest angle. Not too bad. Last one. Ready? Got one more. This is the most difficult one of all. Oh, let's skip it. Yes. All right, so we got a piece of land. The southernmost boundary of a four-sided piece of land is a river. The other three boundary lines are 285, 564, and 322. And the northernmost angles are 98 and 105 respectively. What is the area of the piece of land? Is it possible for an area of piece of land to not be a perfect square? Yes. I don't know how Colorado got to be the way it is for shape, but that's kind of odd. I mean, doesn't really happen too often. If you're small enough like Rhode Island, we don't really care, right? It's like, don't count. Half an hour from one side to the other doesn't count. So this, though, totally different scenario. This is a lot of land, and we want to calculate the area of land. Why would you want to know the area of a piece of land? If you want to buy it, plant crops, know how much seed to buy, fertilizer. for tax purposes, okay, so we tax based on the amount of property that you own. So, government needs to figure this stuff out as well. They need to do it on a three-dimensional surface because, that. So, that's what you have to do. So my dad's a land surveyor, so this is a classic example. So, these are real applicable problems. They obviously have technology that helps them out, but the same type of setup is important. So they have to at least find those dimensions. Once they find those dimensions, computer does it for it. We're going to do the job of computer today. We're going to find out this area. Area, I've got a formula. Area equals 1/2 base times height for a triangle, but we've got this great formula. Area equals 1/2 AB times the sine of C, or 1/2 times 2 sides times the sine of the included angle. The formula for the area of a triangle is excellent for solving these kind of problems. I don't have a triangle shape. This isn't a trapezoid. It's not a parallelogram. It's not a rhombus. This is just a quadrilateral. There's nothing special about it. So I can't find the area of this quadrilateral until I divide it up into two triangles. So I'm going to take it, divide it just like that. I got two triangles. I got triangle 1. I got triangle 2. Do I have enough information to find the area of triangle 1? Yeah, I do. In order to find the area of triangle 1, all I have to do is 0.5 times, go with 0.5 times 285 times 564 times what? 998. That was easy. We're halfway there. $79,587.84 square feet. Yeah, so that's more than an acre of land, right? It's about 1 3/4 acres of land. So that's just that one triangle. We want to find the other one. In order to find the other one, what I need to do is I need more information. I got this side, but I also need a secondary side, don't I? I don't have this long side. Can I figure this long side out? How? Law of cosines. Cosine says that if you have two sides included angle, you can find that opposite side. So that's what I will do. I will call this C. C squared is equal to 285 squared, which is 564 squared, minus 2 times 285 times 564 times the cosine of 98. Nothing even tricky we got to solve for. We just have to set up the right equation and plug in the numbers. 35 squared, 564 squared, minus 2 times 285, 564, times cosine of 98. Is that my answer? Square root. Oh. 666.38. This is the Satan problem. Gotta find humor. All right, so I've got 322 in Satan. I need to find this angle over here. Never gets old every year. I just wait for this thing. I had forgotten about it, so this morning when it came up, I was like, oh, yeah, all right. All right, I got a story about it. I'll share with you guys a little bit. I need theta right there. I don't know this angle. I know the two angles together are 105. If I could find that angle, then I could find that one, right? Do I have enough information to find that angle now? Yeah, you law of sines. So the sine of 98 over Satan is equal to sine of theta over 285. And a cross multiply. Sine of 98 And then I inverse that answer. 2506? Is that what you got? So can I find the other angle? How? 105 minus the answer. I get 79.94. Do I now have enough information to find that area? Yeah, I've got two sides and the included angle. So to find that area, very simple. Just plug it into my formula. Do I have to take square root of that? Nope. 105, 637. Add them together. That's it. Full area. It's like 4 acres. Got it? So your assignment is do your study.